Hello and welcome to the CS Ed podcast, a podcast where we talk about teaching computer science with computer science educators. I am your host, Kristen Stevens-Martinez, an assistant professor for the practice at Duke University. Joining me today is Philip Guo, associate professor of cognitive science at the University of California, San Diego. Philip, thank you so much for coming on the podcast.
Well, thanks for having me. I'm really excited to talk to you. I've been listening to the podcast for a while. Long time listener, first time speaker, I guess.
Awesome. So today's episode is a TPB, Teaching Practice Byte, or in this case, tool. In a single sentence, what would you say is your tool, Philip?
So the thing I'm here to talk about is a tool called Python Tutor, which is a way to automatically visualize what code does, especially in introductory CS classes. And it works not just for Python, but for languages like Java, C, and C++ as well.
Awesome. So let's start out by talking about where do you use Python Tutor, what classes, and I guess normally I ask how many students, but potentially that is kind of a moot question, but let's see.
Yeah, so the tool is really designed for, I would say, CS0, CS1, CS2. So basically any introductory programming class where students are writing small self-contained snippets of code. So like, implement a function to do X, or write a class and write a test to call it. And, the way I've designed the tool covers a pretty wide spectrum of these. I would say like any problem that you would encounter in an introductory CS class that is what I call self-contained, right? So something that is, that can be completely described on the page, and that also like fits on a page or like a slide of code. This tool will provide a way to visualize what is going on as the code runs one step at a time.
Okay. So I know we're in an audio medium and this is a visual tool, but could you give us a general idea of what the student experience would be when they use the tool so that our audience gets a sense of like, would this be useful in their classroom and where?
Yeah, that's a great challenge. I'll give you just a straightforward example, and then we can talk about the different use cases, both for instructor and student. So I will actually attempt to do this on audio. So imagine you're in Python, and you have a piece of code that's x equals left bracket 1, 2, 3 right bracket, right? So you define x. It's a list of 1, 2, 3, and then the second line is y equals x, right? So just those two lines of code. If you ask beginners, what does that do? They could come up with all sorts of different answers, right? Depending on their mental model, what's going on, especially in that second line. What does y equals x do? It could do one of several things, right? It could make a whole entire copy of that list and then assign y to that. It could also point x and y to the same list, or it could, people have done experiments on mental models in offices. You could imagine x is a variable, it has an arrow pointing to a list, and then y is a variable that points to x, which doesn't seem to make sense if you know Python, but people might think that. Or x and y both might point to the same list, or x and y point to different lists that are both 1, 2, 3. And in maybe a language like C++, y equals x might call a copy constructor and actually make a whole copy. In languages like MATLAB or C++, it might make a copy. But in Python, what actually happens is that y and x are now arrows to the same list. There's only one list in memory. So with a tool like Python Tutor, you can see exactly that happening. You can see that a graphical representation of a name x with an arrow, and there's a list object 1, 2, 3. And the second line, there's a y name and then has an arrow to the same 1, 2, 3. And most notably, the way that you do this without Python Tutor is that you put print statements, right? You would put print statements, or you would use a debugger. And if you printed out x and y, they would both say bracket 1, 2, 3. And you have no way of knowing, especially as a novice, that they're actually the exact same list. So Python Tutor tries to solve this problem by visually representing like what is going on in memory. So that's kind of an illustrative use case there.
So for the actual experience that someone goes through, because I've used Python Tutor actually for a long time, is the first page you just paste in some code and then you click on the visualize button, and then the next page it shows you the code you have, and then it has on the other side on the right the visualizations that you're talking about, and they have a little like next button to see what's going on. I'm just realizing that the prior TPB episode is about tangible physical objects to visualize code, because it's with it was with Colleen Lewis.
Oh, great.
And so this is now the visual representation without the physical objects to help students understand what's going on. So it's almost like you have this transition from the first teaching practice Byte, which is with physical objects, and now this time I'm talking about it in terms of full visual representation on a screen, which I find funny. So the thing that I'm wondering about is that it's called Python Tutor, but one of the reasons why you're on this podcast is that it uses other languages. So how is it potentially different if instead I wanted to visualize with Java or C++ or something like that?
Yeah, it's a great question. There's a running joke for many years now that the name was Python Tutor, but it's actually not just for Python, and it doesn't actually tutor you. So it should be called non-Python, non-tutor. So neither part of the name is actually accurate. But yeah, so back to Colleen's episode. That's great you had her on, because her physical memory models was actually a big inspiration for me to work on the Java side. So it's uncanny because we developed it independently, but actually the visualizations for Java look basically exactly like her memory models, except that I don't have, cute, plushy, stuffed animals. But it's exactly right. There are names, there are slots, there are, she uses strings or ropes. We use arrows, and they're like actual objects that she has, like actual, dogs and tigers and cats and stuff. And we just have, boxes and color diagrams and stuff. So for other languages, the user experience is exactly the same. You paste in code, right? You write or paste in code in just a web editor. It's just a website you can visit. You write code. When you hit visualize, it compiles it in the back end on a server. So for C, C++, Java, it compiles it, and then it produces the runtime execution trace, and then it gives you the interface where you can step through execution. And it's kind of cool. The cross-language aspect is kind of cool in my mind because it's a unified representation. So like, one of the things I've always wanted to do, in the future, in my lack of free time, is to kind of do a more formal study of the, people talk about learning different languages, right? You start with Python in CS1, and then in CS2 or software engineering, you learn Java, or you go from Java to Python, or you go from C++ to Java. And I think the cool thing about using a tool like Python Tutor is that the front-end interface actually looks very similar. So you can hopefully see analogs, right? So if you define an object-oriented program in Python and you define one in Java, the diagrams actually look quite alike because you have the concept of a class, you have the concept of an object, you have a concept of attributes or fields or methods or, a this pointer or something. So yeah, so the user experience is largely the same for these different languages as well. And Java is something I've been working on a lot recently because it's used in AP Computer Science in high schools, in high school curriculum, and also in Intro CS curriculum. So I've tried to make sure that the diagrams really cover the scope of what teachers and students need to know in those classes.
Okay. So we're getting more into the where else could it work and where would it not work part of the episode. So I think a question that I have is, I'm thinking through the key differences between Python, Java, and C++. And so for Java, it has all of those libraries that is kind of like at the CS2 and at Duke, one of the key things that we kind of focus on. Like, do you understand that, sure, you can use an array, but there's an array list and it has all these features to it. And sometimes you have to think through the trade-offs between using one data structure over another and that kind of thing. Can Python Tutor handle that for Java? And then similar question, but for C++, probably the biggest thing is that now you have references, like you have pointers and references, and you can have a reference to a variable suddenly, and that can be very, it's like, pointers on steroids for C++. Does Python Tutor handle that too?
Yeah, so on the Java front, so right now it doesn't do the collections classes. So it just does a built-in array, but that's definitely on the roadmap to show, to actually be able to render, for example, an array list, a linked list, a hash map, set, because conceptually the diagrams have several kinds of, there's a list-like object, there's a kind of a mapping, a dictionary in Python or a map interface in Java, and there's a set interface, right? So yeah, on the roadmap, if we can visualize those in the near future, that'll be awesome. On the C++ front, it does visualize references a similar way to pointers. I guess it just annotates the type. It says this is a, int, whatever, ampersand, so, and it actually, when you're, passing something by reference into a function, it will actually show that both of those, that reference points to the original thing, so that when you're in the function and you modify the variable through the reference, the original one will get modified as well. So references are shown in C++. And also, I think one of the big benefits of this tool for C and C++ is understanding pointers and references, right? Because indirection, even pointers to pointers and, kind of allocating and freeing memory. And those are things that are, quite core to teaching C and C++. And we do show that, which is cool.
So now I'm curious, you said allocating and freeing memory. How is that shown in Python Tutor?
So the memory model there it's still a bit abstracted, right? So it's not showing like literally all the bytes, right? It's not like here's like an array of memory that you allocate. So it's shown, if you again, I'll do this by audio, right? So if you have a line that says, int star x equals malloc, 5 size of it or whatever, when you run that line, what will happen is that it will show that x is a variable and it points to a block of memory that is, on the heap, and it's actually 5 ints, and they're all question marks because when you do a malloc, it doesn't actually fill in the memory with anything. They're all uninitialized. So then the next line, if you start filling in stuff like, x bracket 3 is a value, then only that one gets filled in. So it's actually memory accurate in the sense of it will show what has been allocated, and it will actually show what's been initialized as well, so that you don't actually print out, these garbage nonsense values, which you would if you had GDB, right? If you use a debugger and you try to look at it, it would print out uninitialized values for you, which is confusing potentially.
So does this mean that Python Tutor could potentially show a student when they have a runaway memory leak?
Yeah, so let's see, what happens in that case? Yeah, I mean, I think that what it does show is if you're trampling over memory you're not supposed to. So because it's a faithful representation of the stack and the heap, it can actually show, especially on the stack, right? Like these sort of stack overflow or buffer overflow things, it will show that. I think what happens on the heap is that so basically, I mean, I don't want to get in the weeds too much for this podcast, but it uses Valgrind, which is a memory safety detection tool. So Valgrind is a tool that allows you to basically track what memory has been allocated or initialized, so that the visualizer uses that. So what Valgrind does, though, is that if you go out of bounds, it actually issues an error. So it actually puts kind of a memory safety layer on top. So like you can't just keep going out of bounds, because as soon as you're out of bounds, it'll throw an exception and it'll terminate the program. So, but the thing is, on the stack and in the globals, you can trample over anything because that memory has always been allocated. So you can actually come up with examples where you have a pointer to something on the stack, and then you just start doing arithmetic and walking over it, and you're just clobbering other values on the stack. And that's what really happens if you have C and C++ code, and it's something we illustrate. So which is cool.
Oh, I think that's hilarious. I feel like there's some security professor that could like take this as an example and tell their students like, this is how we're going to learn how to hack pointers.
Yeah, I think that would be an awesome use case. And in fact, again, I don't want to super dive into the weeds of this particular tool, but like I made a view recently that's actually like a bit level view. So you can actually expand every byte of memory. You can see the ones and zeros, which is useful for if you want to show like low level operations, right? If you're teaching C, you can teach like bit masking, bit shifting, also different sizes of integers, right? So like you can show if you're assigning an int to a short or something, it actually just truncates the higher whatever 16 bits, and you can just see literally the same number, but like only the lower whatever bits are shown. So all of that is in the tool because especially for C, like you want to show sometimes those low level things.
Awesome. I think that's like it's like an Easter egg I wasn't aware Python Tutor could do, but now I'm like, this would never happen in my own class. But I feel like I need to find a professor that like I want you to try and use this as a lesson in your class. This I think would be hilarious. Yeah,
or you can ask them to try to break it too. I welcome that as well, because that will help me to patch things up, and maybe I shouldn't have to do an open invitation to break things, but, I want the tool to be robust and to be, that's part of the ethos of this tool is that it should quote unquote just work, right? Like whatever code you throw at it, it should either work or it should give you an error saying, okay, your code's too big or it runs for too long and times out and such.
So it's good to always talk about what the tool can do, but let's pause and also talk about what the tool can't do. Like, where would it not make sense to use?
That's a great question. Like the way I describe it on the website, if your code or diagrams can't fit on like a whiteboard or on like presentation slides, then it's probably too big for Python Tutor. So, people have been like, oh, wow, can I just paste in, 1,000 lines of code? I'm trying to debug my actual software and use it. And that's obviously a no, because, the diagrams would get too out of hand. So yeah, I would just say the scope is, any code that you want to fit on a presentation slide when you're teaching or on the whiteboard when you're drawing out, if you're in a TA office hour and you're trying to explain how something works, this tool is really, it really is of that scope. Yeah, so anything, if you're in a software engineering class and you need to, push in hundreds of lines of code and external libraries and everything, that's obviously going to be way out of scope for that. The other ways out of scope is that if you need to access files or the network or anything that's not self-contained, right? If you need to read files from a bunch of databases or data files or go crawl the web or something, like we run in a very sandbox environment where you can't, access anything externally.
So let's be super concrete for a moment. And like, what is a literal way that you've used Python Tutor to help your students learn something? So you gave the example about pointers, but let's try a different example.
Yeah, one example that's a classic one is like recursion, right? So if you're teaching recursion, this idea of, you're potentially calling the same function a bunch of times with different parameters, how is that represented? Like the factorial one is like a boring example that everyone teaches first. Just the idea that you could call the same factorial function 5 times, but each time you call it, it's a new stack frame, and the parameter is different, right? 5 factorial, then 4 factorial, 3 factorial, 2 factorial, 1 factorial, and so forth. So with this tool, you can step through it and see at every step you're calling another function, so you're pushing another thing on the stack, and the parameter is different. And then when you, at the base case, you start rolling it back up again so that you start doing the products and the stack frame rolls up, and then the product keeps on accumulating. Like that's something that traditionally instructors have just drawn on the board, right? You're like, okay, I'm going to call 5 factorial, and then we're going to have a new stack frame that's 4, and then it's 3, and then you kind of make marks and and do that. So that's an example of something a tool really excels at, just showing different function calls. So that's something I've used.
So what about future plans for the tool? Like, what are you thinking about?
Yeah, that's a great question. Future plans. Despite me not wanting to jump on the generative AI, LLM, ChatGPT hype, I have jumped on it. So what the latest feature I've actually implemented is this Get AI Help button, which is sort of clickbait because Python Tutor doesn't actually have an LLM or anything built in. What it actually does is it actually pops up an interface that helps you craft a prompt to paste into your favorite AI tool. So the idea is that when you click Get AI Help, it will make a prompt for you that has a little preamble that says like, I'm an introductory programming student. I would like help on Python or whatever. And, please only use constructs that, someone in intro class would know about. Don't use complicated external libraries, kind of tuning the LM to make beginner-friendly code. And then it would paste in your code in the prompt. And then there's a set of preset questions you can ask, like, I think I have a bug in my code, or like help explain this, what this piece of code does for me, or I don't know, add some comments to this code to explain it. And then, the student can write whatever prompt they want, right? But the idea is to basically generate a text prompt that they can go and paste into their favorite tool if they feel like they need assistance with that. So I think that there's a lot of potential in these AI tools in helping students understand in a more formative way.
So let's go with too long, didn't listen. Can you give me a rundown of your practice, or in this case, your tool, in 3 minutes or less?
Wow, this is time pressure is on. Yeah, so what we talked about was this tool called Python Tutor, which you can visit and put a link on. It's just pythontutor.com, or if you Google or Bing for Python Tutor, It'll be the first link. And it's a web-based tool where you go to the website, you pick a language like Python, Java, C, C++, JavaScript, and you paste in your code, or you write your code in an online editor, and you hit a visualize button, and it'll actually run your code on a server, and it will actually come back and show you step by step, just like a debugger, step by step, step 1, step 2, step 3, exactly what is going on in memory at those steps and where your code is executing. And this is a tool that can be used both by instructors to illustrate examples. So an instructor can use it in front of the class to demonstrate, like live coding, or they can use it to make a video recording or a tutorial, they can use screenshots from it to put in a textbook. So it can be used by instructors, which is one half of the puzzle. The other half is that it can be used directly by students to debug their homework assignments. So I think by far the largest user base are students. So they're working on some code for a problem. They don't know what's going on. It's giving some weird exception. They paste in their code to the tool, and then the tool will run the code for them and show them, oh wow, you're getting an exception here because it's a array out of bounds error. And they can actually just go back and forth and see, oh, it's an array out of bounds error because I'm using this variable and I'm off by 1 or something. So then they can revise their code, and they revise their code, they run again, and when they visualize again, they see that the index is always in bounds now, and great, they got rid of their error. So it can be used by both instructors to illustrate and also by students to self-debug. And it's free to use, it's online, and it's and something I've worked on for I think around 13 years now, because I feel old. Yeah, so I've supported this tool for quite a long time, and used it in teaching and supported other instructors in using it. I just love for your audience to try it out and let me know what they think.
Awesome. Well, thank you so much for joining us, Philip.
Awesome. Yeah, it was a pleasure. It was really fun just to talk about both the tool itself and also just kind of implications for instructors and content design and everything else too. It's cool.
And this was the CSED podcast, hosted by me, Kristen Stevens-Martinez, and produced by Chris Martinez. If you'd like to help us stay ad, commercial, and sponsor-free, consider supporting us on Patreon. Link is on our website. And remember, teaching computer science is more than just knowing computer science, and I hope you found something useful for your teaching today.